It's the sum of three numbers and 16, or the sum of three numbers is 16. The largest number is equal to the sum of the other two, and 3 times the smallest number is 1, more than the largest number. Is it supposed to say what is the largest number? All right, another typo I found. The question is going to be, what is the largest number? I don't know how much is getting cut off over there. So, if you recognize this, yes, we did it in class. It's a system of equations, the sum of three numbers. So, I'm going to say S, M, and L are going to be my X, Y, and Z. So the smallest will be X, the medium will be Y, and the largest will be Z. So I know X plus Y plus Z equals 16. I also know the largest number is equal to the sum of the other two, right? So Z equals X plus Y. And then 3 times the smallest number, so 3x is 1 more than the largest number. So if it's 1 more than the largest number, right, I can equal it to z plus 1. 3x, right? I could put a minus 1 over here as well. But you'll see, so here, for me, I like to use matrices, so I need to put all of these into this x, y, z equals a number form. Here, I can move my z over, right? So I get x plus y minus z equals 0. On this one, all right, I can move my z over as well, over this way, but then I need to put in a 0y minus z equals 1. So now I'll put in my 3x plus 0y minus z equals a positive 1. All right, so you have to manipulate your equation to get your matrix here, and then it's just as simple as doing our matrix in our calculator, putting it in the form there. All right, so I'll have to take this off to show my calculator. But you put it in the calculator, right? 1, 1, 1, 3 by 3, 1, 1, negative 1, 3, 0, negative 1, right? That'll be your matrix A. So second matrix, 3 by 3, 1, 1, 1, 1, 1, negative 1, 3, 0, and negative 1. Second matrix, edit your B matrix. That's your solution matrix or your answer matrix. It's a 3 by 1. All right, so 16, 0, and 1. Take the inverse of A times your B matrix. Matrix A inverse times matrix B. All right, so I get this 3, 5, and 8. Again, we're asking for the largest number, so my answer is 8. So that's how we were going to do that one with matrices. Now, if I didn't want to do a matrices there, say I couldn't do it, right? If you get all your equations on here, your x plus your y plus your z equals 16, right? You can use normal substitution, and it actually works out pretty well. The largest, right, so your z equals x plus y, sum of the other two. And then I have 3 times the smallest, so 3 times x is 1 more, so minus 1 equals z. So really, if I look at this, well, I can sub in right here, right, for my z. So I get x plus y plus x plus y equals 16. Well, I could rewrite that as 2 times x plus y equals 16. So dividing by 2, I get 8 equals x plus y. And what do I know? My z, which is my largest number, equals x plus y. So I know my z is gonna equal 8. So I would suggest matrices, right? It'll work no matter what. You could use substitution and use all your formulas, but really, you only need these two to solve this one, right? Again, that was one of our warm-up problems. So check your notes multiple ways, right? Number 2, another 3 by 3 matrix, right? Again, numbers can change, right? Make sure they're all lined up. Here, should be pretty easy. Make sure your y's, x's are all in there. Remember, you're using the coefficients. So in your matrix box, this one should look like this: 2, 3, and 1. 2, 3, and 1. 3, negative 4, and 2. Negative 1, 1, 2. All right. When I'm doing it, I have my x, y, and z. That's what I'm going to return with. Equals my answer matrix, 13, negative 2, and 21. Here's your A matrix. Here's your B. To get rid of the A, we need to take the inverse, right? That'll get rid and leave our x, y, and z. So we multiply the inverse of A times B, and we get our solution. Any questions on matrices like this? All right, there's about 4 where you're gonna do those. So which ordered pair satisfies the systems of linear equalities? There's a bunch like this as well. So these, the easiest way to do these, if you struggle, again, we can plug in these points, 1 and negative 1, or, right, we can use our Desmos. And so one of the things that a lot of students don't do on Desmos that I think you should is actually plug in the points. So if I have this equation, remember I can hit my keypad here to make sure I get my correct inequality. Then go down, x minus 2 is greater than 0, right? So of course, I always like to have red and blue, and know my solution is gonna be the purple, what's in the purple. I can enter these points in. So I can have negative 1, comma 2. I can put 0, comma 1, if I can type. 1, comma 1. And 4, comma 3. I can put all these points in here, right? And I can see which of these points, did I put in my points correctly? This one needs to be a negative 1. All right, make sure your points are in there correctly. But once I do that, I can see which of these fall in my double shaded region, and it looks like none of them do. Why is that? Well, this should be a y. X minus y is greater than 0, x plus y is less than or equal to 2. Go slow, make sure you don't make simple mistakes, right? So I see I have these points here. The only one in the double shaded or the purple region is that 1, negative 1. You can do this on all of the inequalities. Again, you can plug these in for your x and your y to check to make sure they justify these equations, right? They're not gonna equal, but the inequality will be true. So again, another inequality, just the same thing. We can plug in these points to make sure that they equal. Remember, it's the double shaded region that we are looking for. Again, another inequality, looking for the double shaded region. All right, so let's talk about this system of inequalities. So it's not asking for anything besides the matrices. Here, it just wants you to be able to know what the matrices looks like, how to express that as a matrix. Remember, it's your coefficients only, right? Times your x, y, and z equals your solutions or your answers, right? So coefficients of my equations times my x, y, z equals my answers. There are two that are just like this, right? If you just know how to plug in a matrix, right, you should be golden on this. The one on the final is actually like this as well. The final is really easy compared to all the tests we take in here. But they don't even make you do the matrix. And here we're gonna do a bunch of them. But that's all you have to do is know how to plug in that matrices. All right, again, I have another system of inequalities, looking at that double shaded region, what point justifies it? On number 8, I have another matrices, right? It is all lined up for you. Just put it in your calculator in the matrices. Now you could work this by hand. You could use substitution. You could eliminate your z's. If I was doing this by hand, I would immediately think, all right, I have a z, a negative z, and a 2z. So I'm gonna eliminate my z's, right? Then I can get it to a 2 system, and then I can plug in. So you can do this, I mean, you can do all of them by hand if you would like. The easiest way, of course, is gonna be use your matrices. Would anybody like me to do this by hand? No? Okay, that's fine.
Wait, can it also be used by just Desmos, or because it's a fully functioning Desmos, then could this also use in Desmos, or is just matrices the best way?
So the problem is the Desmos
wait.
beta has
wait.
Z, but your regular Desmos does not.
Okay,
so
sorry.
Desmos, as of right now, doesn't have 3 dimensions. It looks like it's going to, because there's a beta that does have it, but right now you're gonna have to use matrices to solve these, right? Anytime you have 3 variables, you'll have to use matrices to use the calculator. Now you can solve them by hand, and like I said, right, if you add, just your first 2 together here, right, well, your z's are gonna cancel. Then you can use these 2, right? Multiply the top by -2, right? Get your z's to cancel again. Have those 2 equations, and now you just have a regular system of equations that you work with. And then you could use Desmos to solve that, and then you could plug back in, right? So there are ways to kind of use the calculator, but you have to get it down to 2 variables before you would use that, right? Because your Desmos isn't gonna have a 3 variable solution.
Proud of that.
Does that make sense?
I think so. Another random question you already talked about. Matrices work perfectly with this one, right?
Yes.
Okay, so sure.
Yes, matrices, put this in the matrix. Your matrices, right? I'll go ahead and go through it. Remember what your A matrix will be: 5, 2, 7, 2, 3, -3, Y, 1, -1, 2, right? There's your A matrix. Your B matrix, right, would be -11, 17, and -4. All right, you'd have this multiplied by your X, Y, and Z. All right, so that's what it would look like. You only need to put these 2 in. It's gonna return this answers, right? Take the inverse of your A. All right, multiplying by the inverse cancels out. So multiply by the inverse over here. Inverse of A times your B. And what you're left with is your solutions there.
Gotcha.
All right. So again, you could use Desmos. You could get to a 2 system and use Desmos if you wanted to here. If you have brain fog and you forget how to do matrices, you can get to a 2 system of equations and use Desmos. All right, over here, right? So this is just like our color by number sheet, right? Where we have -x, we have an x squared, right? We have a 4, we have a linear, so we have a quadratic and a linear. We can sub in here. Now I know what you're thinking, can't we use Desmos on this? Yeah, you can, but let me go ahead and solve this one, right? So I get -x squared plus 4 equals 4x minus 1. So remember, I want to move everything over to one side, So I'm gonna move this 4x. I'm gonna add this 1. So minus 4x plus 1. All right, so this becomes negative x squared minus 4x plus 5. So when it's me, I don't like working with a negative leading coefficient. So I'm going to multiply the whole thing by a negative 1. I'll do it on that side, but it doesn't change my 0, right? So my new equation will be x squared plus 4x minus 5. Then I can put it in my box. What times what multiplies to equal 5 and adds up, or multiplies to equal negative 5 rather, and adds up to a 4. All right, so I could have negative 1 and 5, or I could have a positive 1 and a negative 5. Remember, I need a positive 4 though, so I'm going to choose my negative 1 and my positive 5. All right, that'll give me 5x, negative 1x, that adds up to 4x. So my two factors are x minus 1 times x plus 5. Set those equal to 0. So x equals a positive 1 and x equals a negative 5. All right, once I have my x values, yes, you can check to see which x values you have, right? Looks like the only one that has 1 and negative 5 is a. So I'm pretty likely going to choose that one. There is one that does have 1 though. So I'm going to go ahead, remember you can just plug these in to your simple linear equation. So I get y equals 4 times 1 minus 1. 4 minus 1 is 3. So when x is 1, my y is 3. So 1 comma 3 is one of my solutions. When my x is negative 5, so I get 4 times negative 5 minus 1, so negative 20 minus 1 is a negative 21. So my other solution is negative 5 comma negative 21. So you will find those points on Desmos. You will have to kind of zoom out a little bit for your negative 5, negative 24. That is where that graph intersects that line. So why don't I show you that just so there's no confusion here. I know my screen is frozen. I will unfreeze it here in a second. So I have negative x squared plus 4 and 4x minus 1. So Desmos will look something like this. If you type those in, right? We have my upside down parabola. This point, obviously pretty easy to find. I can find it. Oh, I know it's right here. That's at 1 comma 3. But my other point, oh my goodness, way down here, right? I think it's something like right there. Right, which is negative 5, negative 21. All right, so you can find these on Desmos. You can do the math. You can double check your math with Desmos. I think that is the best option. So moving on, now we have a system of linear equalities with 3 linear equalities. So really important here, if you're going to use Desmos, make sure you know this is the triple shaded region. So if I use Desmos on this one, right, I know I have y is less than 5. I have y is greater than negative x. And I have y is greater than x. All right, so what I like to do, I like to use my red and my blue, again, to get purple, and then I like to use black. So I know my answers have to be in dark purple. So dark purple is this little triangle right here. I can enter in those ordered pairs to see if anything is in those triangles. There you go. Negative 2 comma 4 and 3 comma 5. So I see a lot of these are out, and here is this sneaky little red one, but it's on a dotted line, right? Since it's on the dotted line, right, that means it's equal to or less than. It is not part of our solution. The only one that will be is this -2, 4. Again, I'm going to change these ordered pairs up, so make sure you put them in here, right? If it's on the line, right, it is not part of the solution when they're dotted lines like that. Any questions on that one? All right, let's talk about a conceptual one. So, the following system of equation models population N of 2 organisms after T days. Solving the system shows that the population 2 values of T, I get T equals -1 and T equals 4. So, what do I know about the equation? Well, we're talking days, right? So anytime I get a negative answer when I'm talking length or time or days, I know that's not part of my solution. So this one, pretty much the only people that are probably going to get this one right are the people who come to the review. The answer on this one is the solution. -1 is invalid because negative time, I wish it existed, but it does not provide a feasible solution in this situation. All the other ones are correct. This is how you solve the equation, but -1 is invalid because negative time does not exist. All right, so when you get to one of these conceptual quadratic system of equations where you have a quadratic and a linear and you have a negative answer and it's saying your t, that should be a dead giveaway, equals -1, understand that that is not feasible because time cannot be negative. All right, so 12 is pretty simple. I give you a graph of a quadratic and a linear. My solutions, right, are those intersection points. Right, so based on the graph, which point is a reasonable solution? So over here, it's kind of in between the lines. It looks like it's at like 1/3, 2, and the other point is at 4, 3. Those are my 2 solutions to this graph. The only one that's up here is this 4, 3, right? Make sure you understand what those points are, count your slope. Don't choose a point that's just inside there, right? The solutions are those intersections, right? This isn't an inequality. Which solution is valid to the system below? Again, I now have another quadratic with a linear, right? So I can use substitution. I can set these two equal to each other. I can solve. I can use Desmos and look for those solutions as well. But I'll go ahead and solve this out. So I need to move everything to one side. So I'm going to minus my 2x, add my 4. Make sure you cancel on the right side. So x squared minus x minus 6 equals 0. What times what equals 6 adds up to a -1. Well, it's going to be x minus 3 times x plus 2. Set those equal to 0. I get x equals a positive 3 and x equals a -2. Once I get those, I can plug those back in, right? So now I get y equals 2 times 3 minus 4. So that's going to be y equals 6 minus 4. So y equals 2. So one of my solutions will be a 3, 2. The other, I plug in a -2. So y equals -2 times 2 minus 4. -2, 2 times -2, right, is going to give me a -4 minus 4 gives me a -8. So one of my solutions is -2, -8. So look for those solutions there. I don't see a 3, 2, but I do see a -2, -8. I like to change these back and forth, right? Make sure you get both of those solutions. Look for the one that's on there. Any questions on these? Basically I'm testing your factoring skills, knowing that you need to sub in here, get all on one side, factor, although you can check via Desmos as well. You can plug it in, you can see those intersection points. All right, let's keep going. Here's another matrices problem, and it's just about setting it up, very similar to earlier, right? This one's a little easier because of the other solutions that have the Y's and the Z's and a bunch of zeros and whatnot, right? So on this equation, right, it is not set up as X, Y, Z. So before you look, right, make sure you set it up and put it in X, Y, Z. So on this one, 4X minus 12Y plus 7Z equals 0, right? Over here, I want to subtract the 9 over, move the 2Z, subtract that over, so it becomes X plus 3Y minus 2Z equals -9. On this one, again, move that 6 over, move the Z over, so X plus 5Y minus Z, make my Z's, equals -6. All right, -6. Why do they have +6? They multiplied by -1 on this one, on the last one, right? So they would get your -x minus 5x plus z equals a +6, right? It is still the same equation, all right? So understand that you can multiply any equation by -1 on both sides and keep that same equation. But honestly, the other answers don't make any sense. All right, you don't ever include your variables in the matrices. You always need to multiply by your x, y, and z, and that equals your constant matrix, right? All right, this one, a matrices, a 3 system, right? But here on my first one, I don't have a z. So what do I need to do? Yeah, just put a 0z. So this becomes x plus 3y plus 0z equals 12. Now I have everything I need to put this into a matrices. 2z equals 11, 2x plus y minus z equals -3, right? Put in your coefficients. 1, 3, 0, 1, plus 2, 2, 2, 1, -1. There's your A matrix, right? Your B matrix over here, 12, 11, -3, right? You'll take the inverse of your A and you multiply it by your B, and that will give you your X, Y, and Z. It's looking for solution Z. Again, you could solve this via substitution, elimination, right? You could use that. You could actually use a combination of elimination and Desmos once you get it to 2 variables, right? But the matrices is going to be your quickest and easiest way to get the solution. All right, let's talk about this one. This is probably my most missed problem. All right, Amy has 18 coins consisting of nickels, dimes, and quarters. She has the same amount of nickels as quarters. How many of each coin does she have if the value of the coins are $2.20? So, James, what are my equations here?
I think it's an X, Y, Z thing. Sorry.
Well, let's use N, D, and Q, right? So I can figure out, nickels, dimes, and quarters, right? But yeah, they're the same as X, Y, Z. So I have N plus D plus Q, and that is gonna equal
18.
18. Now I can also put the values with them, right? So 0.05 in plus 0.1, I'll put a 0, just 10 cents is a dime. 0.10D plus 0.25Q equals 220. All right, now what's my last equation? Same amount of nickels as quarters. So I know nickels equals quarters. Well, how do I get to a matrices from here? Bello, you said it earlier. How do I make this one with a D?
0D, yeah.
Yeah, so what I'm gonna do, right, I can move Q over. So I have N plus 0D minus Q equals 0. So that's gonna be my third equation. N plus 0D minus Q, or negative 1Q, equals 0. Now I have it as a 3x3 that I can put in my calculator and I can solve. Alright. You can also kind of check, right? You can use some process of elimination. Don't forget your test taking strategy. Same amount of nickels as quarters. Alright. Good, good, good. Okay, so they all have the same amount of nickels as quarters. 1 nickel, 16 dimes, 1 quarter. So let's see, that's 165 cents plus 25 cents. So that doesn't equal 220, right? You could do some of that, right? Where you're just adding to see if they equal 220. So, if you get stuck, don't be afraid to work from the answers backwards, right? Figure out which of these are even possible to be solutions. I don't think, there's a couple of these that I don't even think get close to 220. So you could probably figure out the answer just multiplying these back. But best way to do it, put those in the matrices. Now you can't have decimals in your matrices. So this would look like this. 1, 1, 0.05, 0.1, 0.25, 1, 0, negative 1. Make sure your matrices does indeed look like that, right? And again, your answer matrix over here is 18, 2, 20, and 0. Inverse of A times B, that'll get you the answer. And remember, it'll come out as N, D, Q, right? The order that you went in on the first row. N, D, Q. Hopefully you have an N, D, Q every row. So don't forget how to put these matrices in. You can put in the numbers, and you have to put in the zeros to make it work. All right, another one. This one's from our study guide, right? Tim has a collection of quarters and nickels worth $5.35. The number of nickels is 5 less than twice the number of quarters. Find the numbers of each coin. So, quarters and nickels, $5.35. So Q, 0.25Q plus 0.05 N equals $5.35. Then I know the nickels is 5 less than 2Q. So here are my two equations. I can sub in, right? I can use substitution. I could actually use matrices here. Let's see if we can do this. How much time we got? Oh, we don't got any time. So I would put this in matrices form, right? Now this is number 30 on your study guide. So I know I did this for most of y'all, right? You could use substitution. Let's just briefly go over everything that's left on the test. Absolute value, another review problem, right? From our unit 2. Make sure you split it into 2, and when you do, 2x minus 1 is less than 3, and 2x minus 1 is greater than negative 3. Be sure to flip the sign there. All right, continuing on, the linear regression. Again, this is like that warm-up problem. This goes into your L1. This goes into your L2. Then you're gonna hit calculate linear regression. On your years, I think I changed this on the test where I went 1, 0, 1, 2, 3. If not, make sure to change it, right? Don't put it in your years as the full year. Start at 0 and count by how many years you have. You just get the equation on that one. All right, domain of this function, right? These are arrows here. It is all real numbers. It continues on forever to infinity there. Freaky Friday, the inverse of a function. Don't forget, I even gave you the hint, right? All you got to do is switch your x and your y. So x equals 3y minus 8. Solve it for y. Add your 8 to each side. So I get x plus 8 equals 3y. Divide by 3. So y equals x plus 8 divided by 3. All right. Numbers will change. Operation does not. Switch your x and your y. Solve for y. Those are 2 review problems. Over here, it's an inequality. It asks you for which of these written out ordered pairs satisfies, right? We can put that in. Oh my goodness, it even shows the number from the study guide. All right, that's crazy. All right, hopefully we know that one. I know I went over, oh, is that another study guide question? Nuts, that's the same picture. All right, going now. Now this one is very similar to the one I did in class on the study guide, right? You sub in the x minus 1, right? When I do, I get x minus 1 squared. Don't forget to square it, right? If you need to have your box over here, x minus 1, get x squared, negative 1x, a positive 1. So I end up with x squared minus 2x plus 1 minus 7x can combine. So I get x squared minus 9x plus 7x. Look what I did. I left out my x plus 1 over here. X minus 1, distribute. So this is going to be 7x minus 7. So now I can combine x squared minus 2x plus 1 plus 7x minus 7. Right? Where's my plus 1? Did I do this right? So I get x squared minus 9x. It's a negative 7, so that becomes a positive 7. I like to distribute the negative, so I don't do that and mess up my signs. So I do get plus 8. All right, let's see what the other ones we have. We only have 30, not a lot of time left. All right, standard form. Can you have fractions?
No.
Can you have a negative a?
No.
So what is my answer going to be here on this one?
A.
Yeah, it's got to be the one that doesn't have fraction, doesn't have a negative a, right? Hopefully we made that note in our study guide there. All right, pick the graph, right? Put it in y equals mx plus b form, plot those points. Should be pretty easy. That one's from your test. Perpendicular. So basically I'm testing you on finding the slopes here. Gotta find the slope. Perpendicular is opposite reciprocal slope. You need to find the slope of all of these. None of them are in y equals mx or slope intercept form. So you'll have to find those. All right, 2 points. Use your point slope form, right? I think this one's from the study guide as well. So I'll probably have some more answer choices as you go. Another system, this time you're gonna plot the solution as an ordered pair. And the very last one on the test, oh, there's 2 more. All right, solving the system, just a basic system, right? 3 answers. If it has a solution, it can only be 1. And then last problem, Coach Burns bought 1.3 pounds of beef. 1.3 beef plus 0.8 cheese from Midland Meat Market for $11.28. Because his wife wanted more, he bought 1.5 more pounds of beef plus 1.2 pounds of cheese and paid $14.76. All right, once you get there, I trust that y'all are gonna be able to solve You can use the matrices, you can use substitution, you can use elimination. Although elimination will be a little hard because I'm dealing with these decimals here, right? So I'd really have to multiply both those together. I would suggest the matrices, remember when you put it in, it's a 2 by 2 this time. It's 1.3, it's 0.8, it's 0.5, it's 1.2, right? And then your 11.28 and your 14.76? Not the best writing in the world. Take the inverse, multiply, you'll get the answer. Anybody have any questions over this test? That's all the test. Y'all feel pretty confident?